All right, welcome back to another episode of Science with Surback. Today what we're going to be talking about is section 8.2, which deals with the formation and nature of ionic bonds. Our objectives for this lesson is to describe the formation of ionic bonds, account for many of the physical properties of an ionic compound, and discuss the energy involved in the formation of an ionic bond. So we start out here and we start with the definition of an ionic bond. And so it's defined as the electrostatic force that holds oppositely charged particles together. All right, what that is saying is that we have a positive ion, which remember from section 1 we called as our cation, is held together or attracted to that negative ion, which we called an anion. Okay? Now, this all happens because one electron is given away or lost by one atom or ion, and that electron is acquired by another atom. Those things enter a ionic bond. Okay? Now, what happens here is this. Because they exchange that electrons, they enter into that ionic bonds. Now, why or how we get to this point is through chemical reactions. All right? So, a couple of things. One, ionic bonds, opposites attract. So, positive cations are attracted to negative anions. And they exchange reactions, or they exchange electrons through chemical reactions. All right? In typical, what we call our ionic compounds are usually classified into two categories of oxides and salts. Okay? So now, we know, or we have an idea of what an ionic bond is, Now let's talk about an ionic compound. All right? So an ionic compound is any compound that contains ionic bond. So keep in mind what we talked about with that ionic bond business from our last page of notes. And with our ionic compounds, we can have two different ionic bonds formed to make these compounds. The first of which is a binary compound. And so a binary compound contains two different elements. So our examples here is MgNO, magnesium oxide, NaCl, which is sodium chloride. And so again, these are two different elements. Now, we can have multiple of the same elements to be a binary compound, and we'll show you that here in an example, if not in this section, but on section 3. Now, a non-binary compound, you have 3 or more elements. So calcium sulfate, CaSO4, there are 3 different elements. So non-binary has to have at least 3 elements. Most of the time has more than that. Okay, let's put this all together and let's talk about, well, how do ionic compounds and how do ionic bonds, how does that all play together with our electrons? So I start out here with my examples, and I've already put these in our ionic form. And this right here, the charge, is the charge formed when these elements form an ionic compound or they enter into an ionic bond. So again, these numbers, these little superscript numbers, these are the charge. These are the charge of the ion. Well, the question that should be going through your mind is, well, how did we get to that charge? So that's what I'm going to explain here. So magnesium, Mg, remember has two valence electrons. And I'm going to draw those 2 valence electrons with my red pen. And then oxygen, I'm going to do a similar thing here with oxygen. Oxygen has 6 valence electrons. And I'm going to draw these in pencil. And the reason I'm going to do that is because I am going to show how Mg develops a positive 2 charge and how oxygen develops a negative 2 charge. So what happens here? This is showing that one electron is transferred to oxygen, and then that second electron is also transferred to oxygen. We'll draw it up top here. And so what we get here is this. When the compound forms, we would get Mg with those valence electrons, and it lost 2 valence electron. So I'm going to write this down in pencil. Mg loses 2 valence electrons. By losing 2 valence electrons, it becomes a positive 2 charge. So I'm going to put that here. This forms a positive 2 charge. Now, oxygen, I'm going to write this to the side here. Oxygen gains 2 electrons or valence electrons. That forms a negative 2 charge. So the reason that we talk about that, and I extend or I go through this example, is that, hey, when electrons are given from one atom to another, we have a change of charge. We also have ions form. And the third thing that happens is because Mg gave the electrons to oxygen, they now enter into that ionic bond. So they're now an ionic compound. Okay, we're going to do the same thing here with calcium and sulfate here. Okay, so calcium has, again, 2 valence electrons, which I'll show here in red. And sulfate here, it is what we call a polyatomic ion. And for right now, I'm just going to leave sulfate as a whole chunk in brackets. We'll get to this here in a little bit here, talking about sulfate, particularly in section 3 when we get to naming and formula writing. But again, what happens here is that one electron is donated to SO4 and another electron is donated to that SO4. So again, I'm going to simplify this. Ca donates or Ca loses 2 electrons. So Ca loses 2 valence electron, forms a +2 charge. On the opposite side, SO4 gains 2 electrons. So SO4 gains 2 electrons and forms a -2 charge. And we'll talk about these charges and what they mean in a little bit in section 3 when we get to that point. Now, we're going to do the same thing with lithium here and sulfur. Now, I'm going to draw the valence electrons for lithium, which is just 1, and for sulfur, okay? What happens here is this, kind of a weird dilemma. Lithium only has 1 valence electron to donate. So what happens is that sulfur says, hey, I need another electron to fill up my particular outer electron or outer shell. So another lithium comes along and says, hey, I'll get in that bond there. And we have now 2 lithiums bond to that 1 sulfur. And we're going to learn about why that is, and we're going to learn about how to write that formula. But for right now, ionic bonds form because electrons are exchanged that form ions, and they, because as a total result, form these ionic compounds. All right, so let's talk about some of these properties of ionic compounds. And like I said, we're going to revisit this. This will make a little bit more sense when we get to naming and formula writing. So, properties of our ionic compounds. Our ionic crystals here, they have this repeating pattern. So it's kind of cool if you ever take a magnifying glass and you look at salt, table salt. You will see a defined repeating structure, and that's because to form those ionic bonds and to exchange those electrons, a certain ratio has to be met. Now down here in this picture, this is a picture of salt. So you have the green chloride ions and the purple sodium ions. Now, these are very strong attractions because electrons have been exchanged. Now, when we talk about solids for our ionic compounds, they form this crystal lattice. So basically it says, hey, we're going to get this repeating pattern over and over and over again. Now, the more electrons that are exchanged, the stronger something is because we've exchanged more electrons, and so we have bigger positive and negative charge. Now, the other thing to think about here is that when we have an ionic solid that's in this crystal lattice form, it's very hard for electrons to flow. And so if you ever take like a block of salt and you bust it with a hammer, it's going to shatter in a lot of pieces. And that's because electrons cannot flow freely. Okay. So lattice energy is dealing directly there with that crystal lattice. It's saying, hey, how much energy does it take to break apart those positive and negative ions? So again, what all this is saying is that we are taking a hammer, we are hitting it, we are hitting that salt with that hammer, and we're breaking it apart. Well, how much energy takes to break these ions apart is what our lattice energy is saying. The other two things that we need to talk about here, number one is our electrolytes. So our electrolytes, you may have heard that before in Gatorade and Powerade and things like that, but it is going to be defined as an ion in an aqueous solution that conducts electricity. Now let's break this down. Aqueous means you're in water. Conducting electricity here means you have ions. So what happens here is that in Gatorade or Powerade, there are ions that are from ionic compounds. And we'll talk about this in class, and we'll do some experimentation and talk about it in more depth as we go through this, okay? All right, so our last thing that we need to talk about is energy and chemical reactions. Remember, ionic bonds form because of chemical reactions. Where that all comes from is energy involved in that particular exchange. So lattice energy, remember the energy that was in that block, that crystal structure there, is the amount of energy that is absorbed by a chemical reactions. Now remember this, reactions that absorb heat are endothermic, so they take in heat, and I'll write this down, take in heat. Reactions that release heat are known as exothermic. So take in heat is the first one, and our release heat are the exothermic reactions. All right, so we went through this quickly. I hope you have enjoyed this episode. And as always, if you have not done so already, make sure you subscribe.